Today's lesson is simplifying radicals and multiplication property of square roots. You'll get a paper that looks like this, and it's pretty tricky. You want to make sure that when first you cut these out, and you'll cut these out as a whole rectangle. Don't cut along any of these solid lines, just around the edges. Same thing here. These bottom pieces you'll glue in all the way. Stick them down. Now these top pieces where you've got the title along the side, you just want to glue along the edge there and stick it right on top of this edge here. And then you can fold it, it'll open up. So we have here some instructions, simplest radical form. And we've done some of the simplifying already, and then this will just kind of broaden that topic to any situation. A radical is at its simplest form if, number one, the radicand has no perfect square factors. So what's the radicand? Well, if we have a square root of the number underneath the radical is called the radicand, and this symbol right here is called the radical. So no radicands contain fractions. That's number two. And number three, no radicands appear in the denominator of the fraction. So for every number, A has to be greater than or equal to 0, and B has to be greater than or equal to 0. Can't have negatives underneath the radical. And we can multiply radicals by simply multiplying the radicands. So when we have something like radical 4 radical 9, that equals radical 36, which can be simplified to 6. Similarly, radical 4 radical 16 is equal to radical 64. Square root of 64 equals 8. And we do have in our notes, right, 64, 8 squared. So the square root of 64 is just 8 if you go in reverse. Open it up. So at this point, we could go ahead and cut along here. Radical 3 radical 27. So we can simplify that by doing 3 times 27, which is the square root of 81, which is 9. And the square root of 54 times the square root of 6 is equal to the square root of 324, which is equal to 18. You can enter that in your calculator. And the square root of AB, reversing the property, is equal to the square root of 8 times the square root of B. So we could actually divide up this 486 into two pieces. Notice that 81 is a perfect square. So that brings us to the simplified version of this is 9, square root of 81 is 9 radical 6. This is the key example here. This is what your problems in your assignment will look like. On the next side, we have here some more kind of practice. Square root of 4 times the square root of 25 is equal to 2 times 5, which is 10. We could also find that by multiplying the 4 times the 25 and getting square root of 100, which is also 10. Cut this open here. So then square root of 2 times the square root of 28 here underneath the flap is equal to the square root of 576, or 24. And the square root of 48 times square root of 3 is square root of 144, or 12. Now below, we have the square root of 9 and the square root of 49. Which is equal to the square root of 441, or 21. Another way to think about that is 3. Square root of 9 is 3. Square root of 49 is 7, which is 21 as well. Here we have the square root of 64 times the square root of 2. Square root of 64 is 8. And then we just have to leave the square root of 2. That can't be simplified, so I'll write that on the line. 8 radical 2. Underneath, we have here the square root of 363, which equals square root of 121 times the square root of 3. So the way to figure out if there's a perfect square factor within the value in the radicand is to test out the values up to halfway to the radicand. So if we think about 363 divided by 2, 2 goes into 3 once, subtract the 2, we get 16. You can just do this in your calculator as well. 2 goes into 16 8 times. Bring down the 3. 2 goes into 3 1 time. With a remainder of 1. So we'll just look at the 181 here. Go back to our list of perfect squares, and we'll see 181 would happen right here. So I can test out perfect squares below 169. So I can start dividing. Well, first I want to test and see if the number itself is a perfect square. So I could test out, hey, take the square root of 363, and that doesn't work out. So step 2 would be to say 363 divided by 2, 181.5, just like I did here. Could have done that faster. Go over here. Okay. I'm going to start testing things out below 181, which is 169. So I'm going to go back to that number, 363, the original number in the radicand, and divide. So 363 divided by 169 does not work out. So I'm going to go up and try another one, 144. Divide by 144, a perfect square, doesn't work out. I'm going to go up and divide by 121. 3, which is what we already found. We already have that information here, but if you're doing it from scratch, that's important to know. So now, 121, being a perfect square, can be simplified to 11, and our simplified answer is 11 radical 3. 180. Let's try that one. So we'll divide, we'll see, is 180 a perfect square? Square root of 180. It is not. So then, I'm going to do 180 divided by 2 is 90. So 180 divided by 2, probably could have done that in your head, is 90. So then we go over here, and we try numbers below 90. So that starts here. Below 90. It's a guess and check situation. We're doing 180 divided by 81. Did that work? Nope. 180 divided by 64. Nope. 180 divided by 49. Now sometimes you'll notice, 180, there's a 9 in there. And you can jump. But you would have also noticed that there's another perfect square, a larger perfect square. And you need to find the largest perfect square factor. So that's 36. So 180 is equal to the square root of 36 times the square root of 5. Right? Got that. 36 and the 5. So they go back underneath radical symbols, and then we can simplify that to 6 radical 5. And that concludes your notes. You do have quite a few examples, and as always, if you have any questions, please, please, please feel free to ask me.